Hello guys, again welcoming you all for this Dynamics of Machines Laboratory Virtual Lab module. In this video we are going to see the disk type flywheel experiment. Here we are going to compare the mass moment of inertia, theoretical moment and the practical or experimental moment of inertia. We are going to compare by means of adding a metal ball, and we have to adjust the radius and the mass of the metal ball. Through that we have to determine what is the change in actual value, that is experimental value, and the theoretical value we are going to calculate. Okay, so they have given the theory and they have also given the pre-test also. Okay, we know you have to answer all the questions in this pre-test. Let me answer for the third question here. What is the moment of inertia of disk type of flywheel? For this type of flywheel, we know moment of inertia is equal to I is equal to mr square. This is all usual. But when comes for disk type, the mass moment get reduced to 0.05 times due to the loss of the structure. Therefore, I is equal to 0.5 mr square is actually the formula. While solving the flywheel problem in the second unit, turning moment diagram and flywheel, we have to study this. We know this, right? So we'll check whether it is yes it is right. 1 out of 5 is right. Likewise you have to answer all this. Okay, after this pre-test we'll move on to the experiment through the simulation. Okay, see here, this is the actual experiment. This is the simulator box. Here the speed is 2 times and they have given the mass, that is capital M of the disk, it is 37.8 kg, and they have given number one, n1 is revolution, number of revolution it will take, and the radius in terms of meter they have given, as well as the torque value. And we can adjust two things here. One is the capital R, radius, in terms of centimeter they have given. Okay, I can reduce or increase the radius. I am increasing the radius to the maximum till 18, as well as the mass value. What is this mass value? 0.6 kg wheel cap. Okay, whatever we can keep it as usual. Let me take 0.5. Okay, again nothing wrong in that. Okay, so they have given the height also. This is the mass of the ball, steel ball. This metal ball is going to drop down from the top to bottom because of the rotation and the speed. Once the speed is reached twice, that is here 2 times now, which will changes to 4 times. On that they will give some calculations. Then we have to give the result through this calculations. Around simulated results calculation will be observed here. From this observed value we have to make the calculation and derive the actual and experimental values and check with the result. Okay, let me simulate. Just look at here, the speed of the drum is getting rotated, as well as the metal ball is getting fallen, which once it reaches the ground, see the speed is after release of ball, it was 4 times the speed. Once after a while it get reduced, because the revolution and the kg, after this it will get reduced. So after reduced and after it reaches to the stop point, we'll get the calculation or observation for this experiment, and those will be the timing they will be given in terms of timing, as well as revolution also sometimes they'll give. Let me check with that. So since the radius is increased as well as mass value is increased, which is actual value, it is get changed, right? That is why it will take more time to respond. It need to stop completely so that the calculated observations will be displayed. Now see, it will take 50 seconds. Okay, for dropping from the 0 meter to 2 meter and dropping until start to end, it requires 50 seconds. As well as they have given the radian per second, angular velocity they have given. Angular velocity for this, from the speed we can determine. Okay, they have given n1 17 revolution and n2 here 305 revolution. So changes, we can observe the changes here, right? So now what is the theoretical moment of inertia value here, and we have to, what is the experimental moment of inertia, we need to calculate and to look over the result. Okay, theoretical value kg meter square. We know kg mass is 65.34, okay, and the radius is 18 centimeter. Converting it into a meter, we have to again to substitute some value and to calculate what actually it is, right? Radius and everything we have to calculate. Let me check with 0.9 or 0.8. okay, let me use 0.8. again the same value. Let me check 0.9 here and we'll compare the result. Okay, just see, theoretical moment of inertia value is 1.058, experimental moment of inertia value is 1.061 for this case. okay, so எதுக்காக நம்ம 0.8 and 0.9 நம்ம போட்டோம் அப்படின்னாக்கா, while substituting this mass moment of inertia formula நம்ம substitute பண்ணோம்னா we'll get this. okay, moment of inertia formula we know, kilogram meter square. So this is what, so the percentage of error or the percentage of changes from the actual value for both the theoretical and experimental moment of inertia has been given, which was around, it is not, it's quite good actually, the value is quite good. 15 and 25% of error is acceptable. It should not be more than that. okay, some cases it varies. okay, so let me start again. Here see, I am reducing everything. Radius was 15 at the beginning, right? So I'll keep the beginning at 15 and the mass is 0.2 kg. Now reduced mass, it will take lesser time. You can see now. So on that time it takes 50 seconds to complete the speed. 2 times will reach us to speed 4 times. After reaches 4 times, the mass gets pinged over here. That attached ball will reach us the ground. After then it reduces its speed and come to a rest position. Once after coming to its rest position, the calculation values will come. For this calculated calculations, from this values we have to determine the theoretical and experimental value of mass moment of inertia. okay, which was 51.7 seconds, and now we can take which was 0.8 and 0.9. so now the value get reduced, because for the mass of 30 kg and the mass of mass of 0.8 and mass of 0.2 as well as radius is also getting reduced. okay, so it might be 0.4 or 0.5 for both the cases. Let me take 0.4 here. Submitting it, we will get a result of, see, both the actual value is 0.42 and 0.43. so percentage of error is 17 and 8%. So this is how we have to calculate the change in percentage of the errors. okay, so this is all about this, and they have given some post test for this experiment. Try to answer the post test questions. For all the questions, try to answer this and look over the references and give the feedback for the same. Thank you all guys. Thank you everyone.